Hello friends, welcome to PansimTech Private Limited. So today I'm going to present what is CFD and what are the different process of CFD, and later on what are the different governing equations, and how we are getting that governing equations, etc. That we will take take care of these all governing equation derivations like continuity, momentum, etc. in our courses. So let me tell about something brief about PansimTech Private Limited. So this is our technical headquarters. It is in Kolkata, and our business operations we are doing from NCR, Delhi, and Kolkata as well. So what we are doing exactly? We are doing R&D services, like we are providing simulation services to different industries, product development, CAD CAM, verification, validation. These all terms you will understand after this course, and we are also providing some academic and corporate training. For that you will get some certificate, and we are also providing mentoring and staffing. So we have some several connections where we can put our staffs, contractual staffs or permanent staffs. That depends on the requirement. And if suppose the persons have already softwares, but they don't know how to execute that software, so we have dedicated expertise team, so we are doing mentoring for that. Okay, so now let's coming to our next agenda or next slide. So now what is CFD? So before going to the CFD, what are the different historical evolution of CFD that we need to understand? So left hand side, if you will see, so CFD starts with the very beginning, maybe late 1940s. And as the computer become more powerful, engineers' mindset became more mature. So researchers saw the potential. Okay, now using complex physics of fluid mechanics, integrating that complex physics into some different numerical schemes, and solving some techniques of uh, numerical mathematical model, uh, basically big matrices, you can say. So after that you will come to know, okay, maybe subsequently you will come to know what exactly I want to say related to this complexity. So in simple terms, you want to understand that, okay, if what we are doing, so we are simply solving numerical schemes which will behave same as physical product. So what is CFD? CFD is nothing but it is the branch of fluid mechanics that solves high complex governing equations. Continuity. What are the governing equations? That right hand side you can see here, that what are the governing equations. So from here you can see, so continuity equation, momentum equations, energy equations. So these are governing equations. So momentum equations, if you are considering if you are not considering viscosity, that will become Bernoulli or Euler equations. But if you are considering viscosity, that will become your Navier-Stokes equation. So if you are considering turbulence flow, so that means mean fluctuation parameters into the Navier-Stokes equation, that will becomes your RANS model. So Reynolds average Navier-Stokes equations, where we are solving our mean part. So and what are the different process of CFD? So it involves basically three main steps. So as I told earlier, that what is the intention of CFD? So basically to understand the product or something which is virtually available, that means available in CAD but not available in physical, even though it in the beginning stage. So we calling that is what? Virtual prototyping. Virtual prototyping means, suppose one fan is there, but uh, CAD of fan is there. We don't have physical fan. So we can check the performance of fan, efficiency of fan with the help of simulation. Then we will decide, okay, this type of fan efficiency, what is the specification from, for that we are going to build the product. So this is called virtual prototyping. So all the calculations or the all the precautions we will see in the beginning itself. Now, what are the different steps of CFD? So basically, CFD has three main steps: pre-processing, solving, and post-processing. What is the pre-processing steps subdivided into? Suppose if you are getting the geometry, that may be quilts, that may be surface error, that may be something. So we have to defeature that geometry, that we are calling as cleanup, geometry cleanup. And later on, if that geometry is that geometry itself is a big control volume. if we are dividing that big control volume into small control volume, that we are calling it as what? We are dividing a big domain into subdomain, and even if subdomain, that means discrete element. So that in individual element, if we are connecting together, we'll call as mesh. So what is mesh? Dividing a big domain into small networks that comprises of, in 2D we are calling it as uh, you can say net, uh, basically like tet, tetra mesh. So but in terms of 3D we are calling this triangular mesh or tetra mesh into tetrahedron mesh. Now what are the, after getting the mesh, we have to do the case setup. So case setup means assigning the boundary conditions, proper boundary conditions. The boundary conditions should be as real which will behave, which product will behave. So that is why we are calling it case setup. Okay. Now after the case setup, we are solving the equations, and after solving equations, you will do the post processing of that solved equations basically, and after post processing and analyzing the results. That's it. So now coming to the next slide. So okay, now here if you will see, so each continuity equation, each governing equations like continuity, momentum or energy. So if you will see energy, that is comprises of non-linear equation. So it is not possible to solve non-linear equations so easy. That is why we are doing discretization of non-linear equations into some algebraic equations. That algebraic equations we are solving with the help of commercial software. That commercial software, in market there are lots of commercial codes are available. Sometimes people are using their own code. So we'll come to that in our next video. What are the different commercial softwares available in the market? What are the most demandable software, etc., etc. Now coming to the next slide. Why CFD we are using? So we are using CFD because of various purposes. Suppose if we have product, and if we want to eliminate some parts, simultaneously we want to check either it is either their performance is changing or not. We don't want to change the performance of the product, but we want to change some parts or maybe dimension of the parts so that we can save some cost. So in that scenario, cost reductions we can do with the help of CFD. By doing some flow thermal analysis, it is possible to do, it's possible to check the performance of the product apart from change in the various child parts. What are the different product development? Same things. If suppose the right hand side you are seeing the picture of refrigerator. If you want to see, check the position of the tray. So if we are changing the position of the tray, how the simulation is behaving or how the product will behave, that we can see from the help, with the help of simulation. So that we are calling it as product development. Hopefully clear about product development. Now coming to the next point. Suppose if you want to change various type of changes in the product. If we are doing in terms of test, you have to buy the product or you have to order some, we have to assemble a physical product. So create a physical product itself will take more than 6 months or 6 months to 1 year. But in virtually you can do CAD creation within 1 month, and changes we can do within weeks like that. And each weeks you can get some results. So that means it is faster results we can get without any physical prototype. Now coming to the next point, study of flow visual. Similarly, from the right hand side, you can see from the picture that okay, what are the different flow visual? So internal flow visualization is very difficult to see in any experiment, but here you can see from the CAD. Even you can see the sectional flow visualization, how the flow velocity or thermal behavior we can see, that we can see it from the sections. Design optimization, if you want to change something in the design and you want to see what is the optimal behavior of that design, so something like bell type of curve we'll see, and whatever is the optimal value that we can get. Early risk warnings or detection in the design. If suppose there is any faults in the design, you can get it from the beginning stage. That means your final product, instead of failing that product, you can get your early warning sign. Parametric study, suppose if you want to change something in the parameter. Let's say if I am taking one example of let's say fan blade. So the blade of the fan, the root and tip angle of the fan, if we want to do the parameters, let's say radius, if we are, if leading edge of the radius, what is the meaning of leading edge and trailing edge? So if we are drawing this aerofoil shape type of fan, let's say here, so this is called leading edge. This is called leading edge, and here this is called trailing edge. If you want to change the angle of leading edge and trailing edge, and if you want to see the how this aerofoil shape fan blade is changing, that means that study is called parametric study. Parametric study, that any type of thing, it's only I'm giving example of fan, it may be anything, it may be anything. Let's say here in this refrigerator you can see the, if suppose the length of this tray, how the where the flow is recirculating, like say here. So if we want to increase this length of the plate from here to here, so that means we are changing this at by each length. So what is the parameter here? Length is the parameter here. Now again, another thing, environmental impact assessment. If suppose nowadays BS6, we are handling BS6 in automobile. Government told, okay, now you have to increase to BS8. So this much pollutant we have to reduce. That in the beginning, before telling the government, we can predict with the help of EGR, means what? Exhaust gas recirculation. That means portion of the exhaust gas we can again reinsert into the combustion chamber, so that we can reduce the noxes. Noxes means harmful gases or pollutants to the environment, to maintain the government norms. It may be in India it is BS6, in Europe it is Euro 6 or something like that. So we have to follow the norms, and because of that we can predict what can be happened in BS8. Suppose by changing the parameters in EGR device. So that type of things can be done with the help of CFD. Now coming to the extreme environment condition. Let's say there is one particular device which is where the ambient temperature, that means surrounding temperature of that device is minus something. Let's say minus 50 degrees C or maybe minus 10 degrees C. Is it possible to go in that extreme environment condition? No, because it may harmful. We have to take lots of precautions before going to that environment. But in CFD, everything we have to do virtually. So instead of going there, we can do it handle here in on computer. Okay, you know that 2 years back or 3 years back, some coronavirus came. In that COVID situations also, this CFD or maybe CAE simulation techniques help a lot. So that because that time we are not able to touch anybody, so that time simulation helps a lot in various different industries. What are the different applications of CFD? It is widely applications to every domain. It may be automobile like airflow or flow thermal or cabin comfort, anything. It may be aerospace like to distribution the airflow simulation to check ice, the combustion gas turbine engine propulsion dynamics, etc. That is aerospace thing. Combustion analysis of aerospace is also big. Aerodynamic noise, aerodynamic heating is also one scope of analysis in aerospace. Waterfall, various hydroelectric things we are getting it from the waterfall analysis. So that is one example. Waterfall means what? To get all the geo impact things, so that we can all the CFD analysis, hydrostatic analysis or hydrodynamic analysis we can do in this type of scenario. Ventilation, it may be cabin comfort, as I told, it may be big building ventilation, it may be city planning, it may be smart city, anything. Biomedical, so how the blood flow is behaving, how the medicines are decomposing within the blood, that type of thing we can get it from here. Swimming, there is not any swimming type of thing. Maybe we can say design of pools. So how our, if suppose there are two rows and how the flow is happening, or how the flow is passing from here on the mannequins basically. So that type of thing. So there are lots of different domain expertise have to work with the help of CFD. Okay, so now coming to the next point that okay, we are also arranging some corporates and academic trainings. If you want to take that advantage, you can take it from here. And thank you. And contact us for any type of query. It may be any project consultancy. We are very expert into that, and more than 10 plus or 12 plus experience are working with us. So they are already worked in various big MNCs. So please contact us for any corporate training. You will get certificate for that, and even academic trainings also. If anybody want to take training, so they can take it from us. So thank you for your time. Thank you very much.